Today I'm going to share with you a demonstration of event-driven Ansible for networks. Don't shut my ports! The premise of this demonstration is to explain how to protect mission-critical network infrastructure from both hardware and software failures, as well as human errors and mistakes. What is event-driven Ansible? EDA starts with source plugins. These plugins are used to define where events come from. It's a mechanism for us to consume events and data and pass them to a rules engine to process. In today's demonstration, we will use Kafka. Secondly, we have rules. Rules are defined in a rule book, which is much like a playbook, but this is where we define a conditional structure to describe when actions should occur and what to do in those actions. The actions themselves are things like running a playbook or running a job template that triggers a playbook in the Ansible Automation Platform controller. Or more recently, we've even added the ability to trigger a complete workflow from EDA as an action. So these are things that we can do to automate responses, as well as opening up tickets, creating a feedback loop, and full-blown remediations to provide self-healing networks as an example, which leads us into what are the specific network use cases. So when you look at EDA, it's uniquely positioned to provide us with capabilities to automate a lot of what we do to diagnose network failures and to, more importantly, automate the troubleshooting tasks. So that way we can script out a lot of troubleshooting that would typically take time to define the problem and to determine what that root cause is. We can eliminate a lot of that through automation and reduce the time to restore and decrease the time for failure. Secondly, we can automate opening and closing tickets or sending notifications to the NetOps team. And then lastly here, back to the self-healing aspect, we can actually remediate network configurations that either drift out of compliance or as a response to a failure. In today's demo, we'll see the following EDA components. Firstly, we'll use a Cisco router and enable streaming telemetry so that way we can send an update if any of our interfaces go up or down. Secondly, telegraph collector is used so we can collect the data from the streaming telemetry and convert it from protobuf into JSON as an output to send to a Kafka broker. This is where Kafka will utilize a topic. In this topic, we can use our source plugin for Kafka in the EDA controller to listen for particular data and to react on that data, structured data, based off of the rules that we've provided to look at interfaces and also to check if an interface is down, if it maps to one of our protected interfaces that we've defined as mission critical, then we will react to that with an action to configure the automation controller to launch a job for a job trigger that points to a playbook that will no-shut the affected port, as well as give us some feedback if the interface is up or down as a response, and whether or not we need to continue with further troubleshooting steps. Let's start the demonstration by looking at the EDA controller. First, we need to define a project that points to a GitLab repository where we store our rulebooks and playbooks for the demonstration. From that, we want to take a look at the actual rule engine that's running and the list of protected ports, tunnel 0 and tunnel 1, that we care about because those are our routing adjacencies on that device and are considered mission critical. From here, we'll take a look at the rulebook activation where we can listen to the source plugin. In this case, we're using the Kafka as the source plugin to listen to a topic called telegraph that is the output from the streaming telemetry. As mentioned earlier, we use a project to point to a GitLab that stores our rulebooks, as well as the playbooks that we will use in the demonstration. Let's start with the taxonomy of the YAML file that we use for the rulebook. We'll start with the source plugin, which is Kafka, and the topic telegraph. In the rules, we set the condition to trigger an action based on the router streaming telemetry XPath data for interface state down, and only if the interface is a part of the protected port list that we defined on the EDA controller. The action is to trigger a job template that's called EDA fix ports on the AAP controller. Lastly, we pass the router name and shut interface to the playbook. Now let's run the demo. On the screen you can see I have the EDA controller I also have the AAP controller and a terminal session to router 1. Here we can see the structured data for the XPath for the interface state change that we're passing to the EDA controller to the source plugin. The streaming telemetry will send this anytime the interface state changes up or down. Here we'll verify that our interfaces are in fact up at this moment. In particular, tunnel 0. Now picture, if you will, a complete idiot. Yes, we did just accidentally take down our OSPF adjacency to the core, but no need to bust out ChatGPT to update our resume just yet because EDA's got our back. In the background, we can see that our EDA rulebook is firing and passing the variable information of the router and interface to the job template to launch a playbook for our fixed ports. Here we can see the output of our playbook and our automation controller. And as this concludes, we also have a debug so that we can see that tunnel 0 is actually up and running, as well as a viewpoint from the router directly to ensure that it is truly running on the actual end device, which it is. Tunnel 0 is up at this point. Now let's double click into the change task. And from the JSON output, we can see that our before state was actually false, so the interface was down. And then we compare that to the after state, which shows at this point the interface is true for tunnel 0, so it's up and running. So this is effectively a built-in diff for the actual module that we use for the config module. And lastly, we can drill into the JSON output from our show IP interface brief command that we showed as well as part of a debug in the output. Let's review the job template for our no shut playbook. Here we were able to pass variables by enabling the prompt on launch, so the extra variables that were passed from the rulebook to the playbook, and then ultimately those variables are used here in these Jinja 2 variable placeholders for the router name and inventory as we apply it to the playbook for the router configuration change from shut to no shut, as well as printing out the state of the line protocol with the show IP interface brief command that we looked at earlier. So yay, everything works. I hope you enjoyed seeing the value of EDA applied to networking, and we'll see you on the next demo.